In the last video, we covered deep learning and machine learning. Neural networks form the foundation of AI models, functioning like a baby's brain with layers processing data for pattern recognition and decision-making through weights and biases. Deep learning is sophisticated and uses multiple hidden layers, which are advanced neural networks that extract higher-level features from unstructured data, making it good at learning complex patterns automatically in images, text, and speech autonomously. An example of this is the Specialized Deep Learning Language Model (GPT), Generative Pre-trained Transformer. Deep learning is like a master student who can extract a lot of useful information from massive amounts of data. Machine learning is less sophisticated, using simpler neural networks and curated or structured datasets and knowledge bases, making it good for simpler, more defined tasks with some human guidance. It can learn with limited autonomy through the application of algorithms that help it learn from past experience. Examples of machine learning are Siri and Alexa, which use speech and language recognition to answer limited questions and commands. Machine learning is like a student who reads some books and learns from past examples. Deep learning is an advanced, more sophisticated approach within the broader machine learning family. All deep learning is machine learning, but not all machine learning is deep learning. There are sets and taxonomies of AI models. The taxonomy was reduced to 4 areas: the foundational neural network, deep learning (DL), an advanced neural network, language model (LM), a specialized deep learning model, large language model (LLM), a superpowered language model. The relationship between AI models reflects organic evolution and modifications of AI technology across industries, including performance objectives and learning strategies. AI terminology is nuanced and slippery. Terms like smart and dumb don't mean the same thing as when applied to humans. Likewise, training and learning aren't used the way they are with humans. AI intelligence and learning are more closely linked to specific tasks, autonomy levels, and performance. Going forward, we need to break down what training and learning mean to AI models. Learning in AI. This is a broad process that has to do with model performance. Performance is based on how well the model generalizes and adapts information to performance goals. The calculation process includes creating neural network connections and pattern recognition related to context. There are 3 learning approaches or methodologies: supervised learning, unsupervised learning, reinforcement learning. An example of a performance goal is the ability to recognize a dog in multiple contexts. Training in AI. Training involves the commands, tasks, and calculations used to achieve the learning goals. These processes include adjusting mathematical parameters, like weights and biases and layers, refining mathematical solutions, filtering large datasets, and using algorithms, like backpropagation, to calibrate settings to improve pattern recognition or outcome prediction. An example of training a model to recognize dogs is to input thousands of dog images for pattern recognition refinement. Different from human training and learning. Humans understand, but AI comprehension is mathematical. The outcomes are pattern recognition and prediction, decided by statistical probability. Machine learning uses 3 categories. Supervised learning maps inputs to correct outputs. There are clear input-output pairs. Training data is labeled. Supervised learning example goals are spam email detection, image classification, medical image diagnosis, handwriting recognition, and predicting house prices. Supervised, structured learning with clear guidance. Unsupervised learning discovers hidden structures or groupings. There are no predefined correct answers. AI finds patterns in unlabeled data. Unsupervised learning example goals are customer segmentation, discovering social network communities, anomaly detection in financial transactions, and clustering of similar data points. Unsupervised, independent pattern discovery. Reinforcement learning interacts with the environment for optimal behavior. There are rewards or penalties for actions. AI learns through trial and error. Reinforcement learning example goals are game playing, robot navigation, and autonomous driving strategies. Reinforcement, learning through interactive feedback, human involvement in AI training and AI learning. By now you're probably thinking that all this AI training and learning is fine, but what role do humans play, and is there a job for me? Based on very quick and unqualified research, here is a chart that attempts to connect human tasks and time in training AI using machine learning categories: supervised learning, unsupervised learning, and reinforcement learning. The takeaways are interesting, and I am sure that more qualified people will make corrections in the comments. Takeaway number 1 is probably obvious. Supervised learning uses the most human time and effort. The estimated percentage of time per project is 70 to 90%. Much of this time might be spent collecting source data, whether in the form of knowledge bases or databases is unclear, but possibly both. There is also a lot of time spent defining and classifying that source data. I am thinking of the dog data shown earlier in this video, and the example supports this. It gives a medical use case of using thousands of images to differentiate cancerous from non-cancerous pictures of unknown tissue. Monitoring performance and validating quality is also an important part of supervising the AI learning objectives. This seems like a lot of human work for a very narrow objective, but this needs more specific case studies. Takeaway number 2 is also a little predictable. Unsupervised learning takes approximately half the human time as supervised learning. It appears that there should be reduced time because the humans are creating the template. The template includes initial parameters, datasets, clustering algorithms, objectives, and how to interpret patterns. Having created the guidebook, like a good employee, the AI should be able to interpret data, perform designated tasks, and report on its own progress. The ultimate judge of quality are still humans, as stated in the example of customer groups, probably for sales or marketing purposes. The third takeaway regarding reinforcement learning is very interesting, because it uses more human time than unsupervised learning, and is based on a reward or punishment model. Humans define the reward mechanisms, create simulations, establish performance constraints, and adjust ongoing continual learning parameters. This is a case in which learning never ends. Like the autonomous driving example, there are roles in which a human or a robot can never become complacent and will require continual self-monitoring and external monitoring. Based on this chart, there should be no end of human input or involvement jobs with AI training and learning. The research continues. Next time we'll cover some of these human input jobs in the video. Too dumb for AI?